Journey to the heart of darkness, a voyage through the Milky Way suspended in a sunbeam. Our Earth drifts through the cosmic ocean, a mote of dust in the vast cathedral of space. This fragile oasis, painted in swirling blues and whites, harbors the only confirmed sanctuary of life in a universe spanning 93 billion light-years across. Yet from our terrestrial cradle, we dare to dream of reaching the most violent and mysterious realm in our galaxy, the supermassive heart of the Milky Way. Our journey begins not with rockets and fuel, but with imagination traveling at impossible speeds. We must transcend the physical limitations that have confined humanity to a single world for millennia. The destination ahead is Sagittarius, a gravitational leviathan that warps space-time itself. Located 26,000 light-years from our suburban corner of the galaxy, as we prepare to leave Earth's protective embrace, consider this sobering reality. The fastest human-made object, the Parker Solar Probe, reaches speeds of 430,000 miles per hour. At that velocity, our galactic pilgrimage would consume over 40 million years. But today, we shatter those constraints, accelerating to hundreds of light-years per second velocities that would compress matter into pure energy in the real world. The moon shrinks behind us, that familiar silver sentinel that has guided human dreams and tides for eons. It was humanity's first and only foothold beyond Earth, where 12 brave souls left their bootprints in alien regolith. Now, even that triumph appears as merely the first tentative step in an odyssey spanning galactic dimensions. The solar system's familiar boundaries dissolve into memory as we plunge into the interstellar void. Here, between the stars, space reveals its true nature, not empty, but filled with tenuous clouds of hydrogen and helium, cosmic dust, and invisible dark matter that shapes the galaxy's architecture. The nearest star to our Sun, Proxima Centauri, blazes 4.24 light-years away. In the context of our galaxy, this represents our immediate neighborhood, yet crossing this gap at conventional speeds would demand tens of thousands of years. We streak past stellar nurseries where new suns ignite within collapsing molecular clouds, their birth cries echoing across electromagnetic spectra. Each point of light rushing past our impossible vessel represents a nuclear furnace, fusing hydrogen into helium and releasing the energy that illuminates worlds. Current astronomical surveys suggest that virtually every star hosts at least one planet, meaning we're surrounded by trillions of worlds, rocky planets, gas giants, ice moons, and perhaps even cradles of life we cannot yet imagine. The interstellar medium grows denser as we approach the galaxy's inner regions. Cosmic rays, high-energy particles accelerated by stellar explosions, would normally pose lethal radiation hazards to any biological traveler. These ghostly messengers carry information from the galaxy's most violent events: supernova, neutron star collisions, and the ravenous feeding of black holes. From our elevated perspective, the Milky Way's grand design becomes apparent. We're witnessing a barred spiral galaxy, cosmic pinwheel 100,000 light-years in diameter, containing between 200 and 400 billion stars. Our solar system clings to the inner edge of the Perseus Arm, one of 4 major spiral structures that sweep through the galactic disk like frozen hurricanes. These spiral arms aren't rigid structures, but density waves, regions where matter accumulates temporarily before dispersing. As gas clouds encounter these compression zones, they collapse under their own gravity, triggering cascades of star formation that illuminate the spiral pattern in brilliant blue and white. Older, cooler stars fill the spaces between, painting the arms in golden hues. At the galaxy's center, a pronounced stellar bar extends roughly 27,000 light-years across a rectangular concentration of ancient stars that channels gas inward, feeding the central supermassive black hole. This bar rotates as a rigid body, its gravitational influence shaping the galaxy's entire structure and evolution over billions of years. Dark matter, that mysterious substance comprising 85% of all matter, provides the invisible scaffolding that holds this cosmic architecture together. Its gravitational influence extends far beyond the visible galaxy, creating a massive halo that may spend 600,000 light-years 12 times wider than the stellar disk we observe. As we penetrate deeper into the galaxy's core, the stellar density increases exponentially. What began as isolated points of light now resembles a bustling metropolis of suns. Within 1,000 light-years of the galactic center, stars packed together with typical separations of just 1 light-year to 50 times closer than in our solar neighborhood. Here, any hypothetical planets would bask under alien skies, ablaze with thousands of brilliant stars, their combined radiance potentially disrupting the delicate chemistry required for life as we know it. Stellar collisions and close encounters occur with disturbing frequency, ejecting planets from their orbits and creating exotic stellar remnants. The gravitational environment grows increasingly chaotic as we approach the central parsec, a region spanning just 3.26 light-years, yet containing hundreds of massive stars. These stellar giants, many exceeding 50 times our sun's mass, live fast and die young, exploding as supernova within mere millions of years. Their deaths seed the interstellar medium with heavy elements essential for planet formation, while simultaneously sterilizing nearby regions with lethal radiation. Massive star clusters orbit the galactic center in complex, gravitationally bound formations. The Arches cluster, one of the most massive known, contains over 150 hot, luminous stars compressed into a region smaller than our solar system. These stellar associations represent the galaxy's most extreme star-forming environments, where the interplay of gravity, radiation, and stellar winds creates conditions unlike anywhere else in the cosmos. Our destination looms before us: Sagittarius A, abbreviated as CGR-A, the supermassive black hole that anchors our galaxy's gravitational hierarchy. With a mass equivalent to 4.3 million suns compressed into a region smaller than Mercury's orbit, this cosmic leviathan represents the ultimate expression of Einstein's general relativity. The brilliant accretion disk surrounding CGR aglows with the fury of matter's final moments before crossing the point of no return. Gas and dust spiral inward at significant fractions of light speed, heating to temperatures exceeding 10 billion Kelvin, hot enough to emit X-rays and gamma rays that would instantly vaporize any conventional matter within thousands of light years. Powerful relativistic jets lance outward from the black hole's poles, channeling magnetic energy and matter across thousands of light years at velocities approaching the speed of light. These cosmic lighthouse beams carry more energy than our sun will produce in its entire 10 billion-year lifetime, yet represent merely the overflow from the black hole's feeding process. The event horizon itself, the boundary beyond which nothing, not even light, can escape, spans approximately 24 million kilometers. Time dilation effects become extreme here. Clocks tick slower in the intensifying gravitational field, and the very fabric of space-time warps into a funnel-shaped geometry that defies intuitive understanding. We've reached the culmination of our impossible odyssey, the moment of crossing into the supermassive black hole's embrace. From the perspective of a distant observer, our journey would appear to slow and redshift into invisibility as we approach the event horizon, frozen forever at the boundary between known physics and cosmic mystery. But from our reference frame, we plunge through the event horizon and into the black hole's interior, a realm where our understanding of physics breaks down completely. The singularity at the center, where infinite density and curvature theoretically exist, remains hidden behind the cosmic censorship of the event horizon. Recent discoveries suggest that supermassive black holes like CGR may not be eternal prisons, but cosmic recycling centers, potentially connected to other regions of space-time through wormholes, or eventually evaporating through Hawking radiation over incomprehensibly vast timescales. The information paradox: what happens to information that falls into a black hole remains one of physics' most profound unsolved mysteries. Our galactic odyssey ends not with answers, but with deeper questions about the nature of reality, the structure of space-time, and our place in a universe far stranger and more magnificent than our ancestors ever imagined. The supermassive black hole that seemed like a destroyer reveals itself as a creator, sculpting galaxy formation and stellar evolution across cosmic time. Ready to explore more cosmic mysteries? This journey through our galaxy represents just the beginning of what we can discover together. If this voyage to Sagittarius ignited your curiosity about the universe's hidden wonders, hit that like button and share this cosmic adventure with fellow space enthusiasts. Subscribe to BrightBoundX for more mind-bending journeys across the cosmos, from the quantum realm to the edge of the observable universe. Your support helps us continue exploring the greatest mysteries of existence, one impossible voyage at a time. What cosmic destination should we explore next? Let us know in the comments below, and prepare for your next adventure beyond the boundaries of imagination.